Welcome back to the second video. So in the first video, we have successfully implemented our first endpoints and we can finally get some data from our server. We have implemented a fruit data class that we return as a JSON when we make some requests. So far so good. We can add fruits, but the thing is our data right now is just a local variable inside this function. And when we restart the server, this variable will be reset to this default value. Now, in a real scenario, you want to save your data in some sort of persistent storage. And the most commonly used solution is some sort of database, depending on your needs. In our tutorial here, we are going to use MongoDB. Now, MongoDB is a NoSQL database, meaning that it doesn't have, it's non-relational, it doesn't have relations between different tables. It doesn't even have tables, as a matter of fact. It uses a document-based model. So all data in MongoDB is saved in collections, and each collection has a bunch of documents. So for instance, if you want to save data about our fruits, we're going to have fruit collection, and we're going to have fruit documents inside of that collection. And those documents save data in a JSON-like format, so key value pairs, basically. So to get started with MongoDB, you can go to the blog post here and download and install MongoDB server on your computer. The community version is free, and also download MongoDB Compass, which is going to be extremely helpful because it's going to provide us with a graphical user interface, and we can see what databases we have. We can check out the documents and all of that stuff. So it's really useful when you are learning MongoDB. And when you finish installing these two tools, you scroll down and go to the dependencies. And we need to work with some dependency or we need some library that will allow us to communicate with MongoDB from within our server. And for that, we're going to need some Ktor driver, some Kotlin driver, sorry, to communicate with MongoDB. So previously there was this Mongo library, which was really cool, but at the time there wasn't an official Kotlin driver for MongoDB, but now there is an official one, and Mongo was deprecated by the author in favor of this official Kotlin driver. So we are going to use the official Kotlin driver. So copy the dependencies and go to our project in IntelliJ, and here find the build.gradle file and paste the dependencies here and sync your Gradle by clicking the little pop-up icon that will appear here. Actually, let me just comment this just to show you how the icon looks like. So this is the icon. So you click this and it will sync Gradle for you, but I've already done that. So that's why we don't see it here. So after you sync Gradle, you want to go to the data package here that we created earlier. I'm going to create another package. I'm going to call it, oops, writing in Arabic. So I'm going to call it database. And I'm going to create a new Kotlin file called database. Here, I'm going to create a new variable for the MongoDB client. So I'm going to call this client Mongo client dot create, and here within the create function we need to pass a connection string. So what is a connection string? So basically MongoDB can be installed on the same machine that the server is running at, or it can be running on a completely different server. And also you can use the MongoDB Atlas, which is a cloud-hosted solution by MongoDB themselves, so you don't need to host your own version of MongoDB. So when you pass the connection string here, it will tell the MongoDB Kotlin driver where is your database, so it knows how to connect to your database. For us, because we've installed the MongoDB server, we are going to use the local connection string, which we can get by opening MongoDB. So if you open MongoDB Compass, if you click on add new connection, you are going to see by default it connects to the local MongoDB server. So you want to copy this string and go back to IntelliJ and basically paste that string here. Now, what we want to do, or what we are going to do later, is change this to an environment variable. But for now, I'm going to hard code the string like this. And now that we got the client, we want to get an instance of our database itself. So let's say db is client.getDatabase, and we need a name for our database. So I'm going to name my database bin db. And finally, we need a reference to our collection. So we are going to make a fruit collection. So let's call our variable fruit collection equals db.getCollection, and pass the fruit data class here that represents how the document of the fruit collection will look like. And here the name of the collection is fruit. Okay, so far the setup for the database is complete. Now let's create some functions to insert new documents inside our database, inside our collection. So the first function is going to be add fruit, and it's going to take a fruit of type fruit. And let's return a boolean for simplicity for now, indicating whether or not the insertion was successful. So to insert something in our collection, we are going to do fruit collection.insert1 and basically pass our fruit instance. Now this insert1 function is a suspending function because this we are using the coroutine based driver of MongoDB. Now we need to make this function a suspending function or create our own coroutine here, but we're not going to need to create our own coroutine scope, and you find out why in a moment. But so I'm going to make this a suspending function, and basically that's all we need to insert a document inside our collection. Now, how do we know if the insertion was successful or not? We can use MongoDB's wasAcknowledged function, which will return true if the insertion of the document was successful. Now, also, we can return this, and that will be enough. But I usually like to do my database operations in a try-catch block, just in case something wrong happens. So I'm going to wrap that with a try-catch block, like that. And then put that in a try, and put the return outside of the try like that. And if something wrong happens, we're just going to return false, and then we can print the stack trace here. So this is how we add a fruit to the collection to our database. Now let's make another function to actually retrieve all fruits from our database. So let's name it get fruits, and this function is going to return a list of fruits. Now here, basically what we need to do is access our fruit collection, and then using the find function, we don't pass anything to find right now because we want to get all the documents inside this collection. We don't want to filter anything. And then we basically convert this to a list using toList. Okay, so our functions are done. We now can go to fruit routes file, and let's change this code. So instead of using the variable here, the local variable, let's delete it and use our database as the source of the data instead. So I'm going to basically say fruit list equals get fruits, and that's it for the get part. And if you've noticed, we are able to call the get fruits suspending function from directly here from get, from the get scope, because this scope is also a suspending function. That's the get fruits part. We are going to modify the filtering of the IDs later. For adding a new fruit, what we want to do is, after we receive the fruit from the client, we want to add the fruit using the add fruit function that we created earlier. And this function, of course, returns the boolean, so we are going to use that to indicate to the client whether or not the fruit was sent successfully, was added successfully. So else, if it was not successful, we are going to say respond. For example, bad request, we can say simple response is success false, message can't add fruits. Okay, so let's restart our server and try adding some fruits. Now let's go to Postman here and try to add a new fruit. So let's add this watermelon. Actually, before we add something, let's try to get all fruits. And as you can see, the server returns an empty list because the database is empty. Let's try to add a watermelon, and we get a bad request. Why is that? Okay, oh yeah, of course. Forgot this is a wrong format. The error is right here. So yeah, of course, created successfully. Good. So let's try to add one more thing and create it. Now let's try to get the fruit, and as you can see, the items that we've added are saved in the database. Okay, great. Now let's go to MongoDB Compass and click on add new connection and leave it the default one and click save and connect. Now these are some databases that I have. I'm going to connect, open the database that we have just created right now, and this is the fruit collection, as you can see here. So open that, and as you can see, these are the two fruits that we've just added. But notice something here, that there is this _ID field that was added by MongoDB, but we didn't add this one. That's because MongoDB uses this _ID field as a unique identifier for each document, kind of like a primary key. So if you don't specify it, MongoDB will automatically create this object ID for each newly created document. Now, we probably don't want to do this because, as you can see right now, we've already added apple with ID 1. We can add it again, and if we try to get fruits, as you can see, we have 2 apples with ID 1. So how do we tell MongoDB to not use its own ID and use our field as an ID? To do that, we go to the fruit data class and annotate the ID field with serial name and pass _ID, just like this. This will tell MongoDB to treat this ID as the unique identifier for its documents. So if we reboot our server and go back to Postman, now notice that when we try to get fruits, we will be presented with this internal server error. And that's because if you go to IntelliJ and try to find out why from the stack trace here, you're going to see that the server is trying to read the ID field, and we have declared that it's a string, but the type found is object ID. Because if you look at the database here on Mongo Compass, you'll see that the _ID is an object ID and it's not a string. Okay, and these documents are created before we make this change. So to fix this, I'm going to delete the old documents, and after you delete everything, if you go and try to get all the fruits again, it's going to be a successful API call. Now let's try to add something here. Say that we're going to add an apple. Now if you do that, it's going to tell you that the fruit format is wrong. And why? This is because we have declared that we're not going to have an ID, we're going to have an _ID. So let's make it an _ID and try to add again. Now it was added successfully. Now if we try to add the same thing again, the database is going to return an error because it sees this as a duplicate ID because there's another document with the ID 1. Now if we make this 2, for example, and try to add, it will add it successfully. Now if you go to MongoDB Compass and refresh our collection here, we are going to see the 2 apples that we've added with ID 1 and ID 2, as you can see here. Okay, great. We're adding items to our database, but we have added 2 IDs or 2 apples, but with different IDs. How can we change how can we update this apple? Now in MongoDB Compass, you can just basically double tap here and edit the document from within MongoDB Compass. But we want to do that through our server. And to do that, we can go to the database file, and I'm going to create a new function called update. So suspend function, update fruit, and this function is going to take a fruit and return a boolean to indicate whether the update was successful or not. Okay. So to update, we are receiving a fruit. So we are just going to replace the new document that we passed to this function with the existing document in MongoDB. So let's say fruit collection dot replace one. Now this replace one function takes a filter and a replacement. The filter will tell the collection where is the document that you would like to replace. And how do you define this filter is basically we can make a new variable filter. We can use filters here from the MongoDB library, and then dot eq. Now eq means equals. So our filter is looking for a specific value, and the specific field that we are looking for is _id. We are looking for a specific id, and what id is this filter is going to look for is basically the same id of the fruit that we passed. Because usually, or not usually actually, like when you update a document, you don't change its id. You might change all the other fields, but you never change the id. So we are passing the id here. Now here replace one, we can pass the filter to it and then pass the fruit. Now to know if the update was successful or not, we can use modified count, and since we are updating a single document, we can check if this is equal to 1, and we can return this. So if a single document was modified, then the update, we know that the update was successful. Now let's make a route for that. Let's go to fruit routes. Let's create a new patch endpoint here. So patch endpoint, and I'm going to use the same. Actually, let's just copy the post request here, and then make changes. Change this to a patch, and we receive the fruit, and then instead of add fruit, we are going to update fruit, and here we're going to say can't update fruit, and yeah, that's it. So let's restart our server and go to Postman. Now the apple with ID 2 is what we want to change. We are going to change the name of it to pineapple. So I'm going to open a new tab. I'm going to duplicate actually this post request tab. So I'm going to duplicate this. I'm going to change this to a patch method and go to body. I'm going to change the name here to pineapple. Now send. Now the request was successful. Now let's try to get the list of fruits. As you can see, it was updated successfully. We have an apple and we have a pineapple here instead of the name apple. Now before we implement the deletion, I want to actually make a very important change here. I think it's a very important change, which is regarding the IDs. Now usually you don't want the client to determine the IDs for you. Basically, you don't want the client to tell you what the IDs are for the documents in your database. Those are probably going to be generated randomly. So how can we do that? To do that, we are going to the fruit data class, and here I'm going to give a default value to the ID. I'm going to call object ID and then 2 hex string. This will use MongoDB internal functions to create a unique ID for us, which means that we don't have to pass the ID, and then a new ID is going to be generated. Now let's implement delete. So let's go to the database KT file and delete fruit by ID. So we're just going to pass the ID and return a boolean indicating if it was successful. Now here let's use a filter. We need to create a filter. So filters equals the field is the ID and the value is the fruit ID that we're passing. Now we want to return fruit collection, delete one, pass the filter, and if the deleted count is 1, then we know that the document was deleted successfully. Now let's define the endpoint for this deletion. Fruit routes here, delete. Now the endpoint is going to be delete fruits, and here at the very beginning we need to read the ID parameter sent by the client. So we're going to say fruit ID is call.path parameters. So I'm going to use a path parameter here, and it's going to be ID. So if the client doesn't send an ID, which is required here because we need an ID to know what fruit we want to delete, we are going to immediately return. And let's also respond with a badge request and a simple response of false and a message, which I can't see. Let's actually format this code. Okay, much better. Must provide an ID. So that's if the ID was not sent by the client. If it was sent, we are going to delete fruit by ID, pass the ID, and if the database returned true, meaning that it was deleted successfully, we can respond with okay, simple response, successfully, just like that. And if the deletion was not successful, we are going to return a simple response of false and then say error, can't delete fruit or something. So that's good, I think. Okay, one last thing is for this path parameter to work, we need to define where is the path parameter going to be inside of endpoint. So here I want the endpoint to be /delete, and then we are going to add slash, and here the path parameter, which is the ID, is going to be between these curly braces, as you can see right here. That's how you define where is the path parameter is going to be. Path parameters are very common. You can see them also on YouTube videos. So it's like the URL of the video. Probably that's a path parameter indicating the ID of the video that you are watching right now after youtube.com/ so you can see the ID of the video. Okay, our path parameter is like this. Let's restart the server and go to Postman here. So let's duplicate this, change the method to delete, and instead of add fruit, I'm going to delete fruit / the ID that we want to delete. So let's try deleting ID 1. Okay, so it said deleted successfully. Let's try to get fruits, and the ID 1, which is the apple, is gone. Let's go to MongoDB Compass, refresh, and it was also gone. Now let's delete our pineapple, and it also was deleted successfully. Now let's try to delete the pineapple again, and it's going to say error because it was already deleted. Let's refresh here in MongoDB Compass, and we don't have any data in this collection. Now after we've made the change to the automatically assigned IDs, we can ignore this, and we can now send the other parameter, the other required parameter, which is the name here, and an ID will be generated automatically for our apple, as you can see here. Thank you so much for watching. I hope you find this useful. See you guys in the next video. Bye bye.